So AI agents are incredibly powerful tools, right? You can give them a goal and they'll just work on their own to get it done. But what happens when that goal gets really complex? I'm talking about planning a multi-city vacation or launching a brand new product. These are what we call long horizon tasks. And this is exactly where a single AI agent can start to fall apart, getting lost somewhere between step one and the final goal. So yeah, why do these incredibly powerful AI systems just hit a wall when a task gets complicated? It's a critical question. And the answer, well, it reveals a pretty fundamental limitation in how they're designed.
Imagine trying to be the CEO, the project manager, and the intern, all at the exact same time. That's basically what we're asking a single AI agent to do. And under that kind of pressure, it's really no surprise that it starts to break down in a few very predictable ways.
And these breakdowns lead to three classic failure modes. First up, there's context dilution, which is where the original why of the task just gets totally lost in the noise of all the little steps. Then you have tool saturation. Give an agent too many tools and it gets harder and harder to pick the right one for the job. And finally, there's this fascinating effect called lost in the middle, where the AI can literally forget instructions that are buried deep inside a really long prompt.
Okay, so if one overworked agent is the problem, the solution is pretty intuitive, right? Don't give the whole job to one agent. Instead, you build a team. The big trend right now is to create what is essentially an AI organizational chart.
And this is the core idea behind what we call hierarchical AI agents. It's a system that divides complex tasks among specialized agents that are organized in layers. Yep, just like a company's management structure.
So how does this AI org chart actually work? Well, at the very top, you have the strategic agent. Think of it as the AI CEO. Its job is to set the main goal and create the overall plan. Below that are the manager agents. They're like the project managers, breaking down those big goals into smaller, more manageable tasks. And at the base, you have the worker agents. These are the specialists who execute very specific jobs and then report their results right back up the chain.
The key here is that the strategy flows down and the results flow up. The whole system is designed to mirror how a well-run company operates. Just remember to think of AI agents like employees in a company. It makes perfect sense.
So, why does this structure work so well? Well, it's not exactly a new idea. It's actually a clever application of a classic, time-tested software engineering principle that's just been brought into the world of AI: separation of concerns. Let's compare them side by side. A single monolithic agent is constantly switching between high-level reasoning like, what's the big picture, and low-level execution, like, which tool do I use right now? Its context is the entire massive conversation history. But now look at the hierarchical agent. A worker agent doesn't get the whole history. Instead, it gets a trimmed-down, relevant contextual packet. I mean, an agent whose only job is to format a JSON file probably doesn't need to know the initial 4,000-word strategy document, right? This keeps the signal-to-noise ratio high, and it also helps with that tool saturation problem. Worker agents only get access to a small, specialized toolbox. The security agent gets the vulnerability scanner, but not the deployment tools. It just makes the choice simple and way more effective.
Now, this all sounds great, but it's not a perfect solution. This architecture has some incredible advantages, but there are also some real-world risks we absolutely need to understand.
Let's start with the payoffs. You get better focus because the agents are specialists. A huge one is lower compute cost. You can use your most powerful, expensive AI model as the CEO for the complex planning, but then use much lighter, cheaper models for the simple worker tasks. The system is also highly modular. Each agent is like a self-contained unit you can test, update, or even swap out without messing up the rest of the system. And finally, you get parallelism. Multiple agents can work on different parts of the problem at the same time, which speeds the whole thing up.
But there are perils. First, bad task decomposition. The entire system really hinges on that top agent's ability to create a good plan. If it misses a step or puts things in the wrong order, it's garbage in, garbage out for everyone downstream. Then there's the risk of communication breakdown. It's the classic telephone game. An instruction can get subtly distorted as it's passed down, meaning a worker agent might perfectly execute the wrong task. And finally, there's orchestration overhead. This is a whole system you have to design, managing handoffs and error loops. If that logic is brittle, the whole thing can just fall apart.
So, when you step back, what does this all mean for the future of AI? It really points toward a big paradigm shift, away from a single, all-powerful AI and towards something far more collaborative.
And this is the big idea to leave you with. We often imagine the future of AI as a single, super intelligent agent. But maybe the real path forward isn't building one monolithic genius, but rather architecting brilliant teams, organizations of specialized AIs all working together in concert. So the real question isn't just how smart can one AI get, but how effective can an AI team be?